Good morning, children. So today you are going to learn the second theorem. So in the previous class we have learned the midpoint theorem. So this will be called in short the converse of the midpoint theorem. That's the opposite of the midpoint theorem. So here prove that the line drawn through the midpoint of one side of a triangle. So the midpoint of one side of a triangle. So in the triangle ABC, so the side is AB. So on this side AB, there is the midpoint. So the line is drawn through this midpoint D, parallel to another side. So parallel to another side. So the line that is drawn through the midpoint D of the side AB. So the line is L. This line is drawn parallel to another side, that is the side BC. Then the line bisects the third side. So here now AC is the third side, because this is the first side, because on this side you have taken, they have given D is the midpoint, and through this D, this line L is drawn parallel to the side BC. This is the second side. So the side AC, this will be the third side. So this line L that is drawn through the point D should bisect AC. That means if this line L should bisect AC, in that case the point E must be the midpoint of AC. That means you are to prove AE is equal to CE. So if you prove that these two segments equal, in that case the line L will bisect the third side, that is AC. So in this triangle, here the first side is AB. So through this side AB, through the midpoint D, the line L is drawn parallel to the side BC. This is the second side. Then this line L should bisect the third side. So the bisects the third side. So here the side AC is the third side. That means the line L should divide line segment AC at its midpoint E, which means you are to prove AE is equal to CE. Now for this, you will be doing construction. So here, what you will do is, through this point C, you will draw a line parallel to the side AB. So through the vertex C, we will draw a line that will be parallel to the side AB, that will meet the line L at a point set F. So here we will draw a line that will be parallel to the side AB. So this is the line. So say it meets, say this is E, this will be F. Now already here it is given that So it is given that in the triangle ABC, this is the midpoint of AB. Through this D, the line is drawn parallel. So midpoint of one side of a triangle parallel to another side. So this is the line that is drawn through D. That is the line L parallel to the side BC. This is the second side. Then the line that is drawn through the point D should bisect the third side. That means you are to prove that E must be the midpoint of the side AC, which means AE is equal to CE. Now the construction is that you have drawn through C the line CG parallel to AB that meets the line L at point F. So here how to do? Our first condition will be to make BCFD parallelogram, a parallelogram. So now how to make this one? You will make BCFD parallelogram. So how to make? Since it is given that through this point D, the line L is drawn parallel to BC. That means here DF. So DF is parallel to BC. This one is given. Because the line L is parallel to BC, so DF is Next, CG parallel to AB. This is true construction, which means CF is parallel to BD. CF is parallel to BD. Why? Because you have been through construction. CG parallel to AB. So CF parallel to BD. Now you see both the pairs of opposite sides are parallel. DF is parallel to BC. Then CF is parallel to BD. CF is parallel to BD. Which means both the pairs of opposite sides are parallel. That is why BCFD is a parallelogram. Now that is why, so since this is a parallelogram, that is why their opposite sides are equal. So you got CF equals to BD. So therefore CF equals to BD. And then here it is given that the line drawn through the midpoint of one side of the triangle. So D is the midpoint of AB, which means AD is equal to BD, because D is the midpoint of AB. So you comparing these two equations. So you can say that AD equals, so in place of BD you can write CF. So CF. Now you see AD equals to CF. Now you will make these two triangles congruent. If you make these two triangles congruent, then by simplicity you will get AE is equal to CE. If means AE equals to CE, which means E is the midpoint of AC, then the line L will bisect AC. So by making these two triangles, that is triangle AED congruent to triangle CEF. Now how to prove? So in these two triangles you have got AD equals to CF. So you got AD equals to CF. So you got AD equals to CF. This is proved above. You have proved above. So then the lines AC and the DF meet at point E. So they form a pair of vertically opposite angles. So you will get, say, angle AED is equal to angle CEF. This is vertically. Then one more. As these two lines are parallel, that is true construction. As these two lines are parallel, that is why these two angles are also equal. Say this 1, it is 2. So angle 1 is equal to angle 2. This is due to alternate angles. So it is alternate angles. Suppose. So you got the conditions. So therefore triangle AED, so AED congruence to triangle CEF, so CEF by, now so you took the side AD, you took this angle 1 and you took this angle. So the triangles are congruent by angle, side. So it will be by AAS. So as the two triangles are congruent, so their corresponding parts are also equal. Therefore AE equals to CE. So AE is equal to CE, which means the line L bisects the third side AC at E, because you have proved AE is equal to CE by simplicity. Thus E is the midpoint of AC, which means the line L bisects the third side. Which is the third side? The third side is the side AC. So here we will be proving in stepwise. So here solution. Let in triangle ABC. So let in triangle ABC. So D is midpoint. So D is midpoint. The line drawn through the midpoint of one side. So the side is AB. So through on the side AB, D is the midpoint of this AB. So this is the midpoint of AB. Then such that such that through D, so through this point D, so one side of a triangle parallel to another side. So through this point D, the line is drawn, that is the line L, that is drawn parallel to BC. Through D, such that through D, so line L parallel to BC is drawn to intersect, to means meet the side AC, intersect AC at point E, So this one is given. Now to prove, so the line drawn through the midpoint D parallel to the side BC should bisect the third side. So the side AC is the third side. So the line L should bisect the side AC at point E. That means you are to prove AE is equal to CE. So line L bisects AC. Now comes construction. So through C, so CG parallel to AB is drawn. So AB is drawn to intersect, to means meet the line L at point, so at point F. So now, here in the case of the proof, what you will do is, your first condition is that you are to make the quadrilateral BCFD parallelogram. So by making this figure parallelogram, you can show CF equals to AD. So that CF equals to AD, the first condition is that you are to make BCFD parallelogram. So now in quadrilateral BCFD, so BCFD, so as it is given that the line is drawn through the midpoint D parallel to, so this line L is parallel to the side BC. So it is given line L is parallel to BC. So it is given that DF is parallel to BC. This one is given. And then through this construction, you have shown that CG is parallel to AB. CG parallel to AB. That means CF is parallel to DB. So CF is parallel to DB. This is true construction. Now you see here both the pairs of opposite sides are parallel. DF is parallel to BC. CF is parallel to DB. So both the pairs of opposite sides are parallel. Therefore, quadrilateral BCFD is a parallelogram. Therefore, the opposite sides of the parallelogram are equal. So CG equals to BD. So CG equals to BD. So it is opposite sides of parallelogram. Opposite sides of parallelogram are equal. Let us take this as equation 1. Then again, so CG equals to BD, opposite sides of parallelogram are equal. Again you have got that D is the midpoint of the side AB. So AD equals to DB. So AD equals to DB. Since D is midpoint of AB. Since D is midpoint of AB. So this is equation number 2. Now you compare these two equations. So from 1 and 2, so from equation 1 and equation 2, we get, so CG is equal to BD, BD is equal to AD. So that means CG equals to AD. So CG equals to AD. So you got, so here CG, so here CF. So BCF, so CF equals to BD. It should be CF. CF equals to BD. So here opposite sides of parallelogram are equal. So from this two, you have got CF equals to AD. So CF equals to AD. Now we will make these two triangles congruent. So now these two triangles you will make congruence. So as to get AE equals to CE. So that the line L will bisect the third side, that is AC. So in triangle AED and triangle CEF, so CEF. So you got that AD equals to CF. So AD equals to CF. This one is proved above. So AD equals to CF. This one is proved above. So proved above. Proved above. Then you got these two angles equal. That is, you can give as 3 and 4. So angle 3 is equal to angle 4 because they form a pair of vertically opposite angles. These two. So it is vertically opposite angles. Then you see here CG is parallel to AB. This one we have done it through construction. That is why these two angles will be equal because they form a pair of alternate angles. So here angle 1 is equal to angle 2. So it is alternate angles. Alternate angles. So by seeing these three conditions, so therefore triangle AED congruence to triangle CEF by. So you get this one. So you took this angle 1, you took angle 3, and you took the side AD. So you took this side. So the two triangles are congruent by angle, side. So by AAS. So by AAS the triangles are congruent. So as the triangles are congruent, therefore you get that AE is equal to CE. So AE is equal to CE. This one you got it by CT. Thus line L bisects the third side, that is AC, the third side AC, because E is the midpoint of AC. You have proved it here. So AE is equal to CE, that one you got it by CT. So here E has become the midpoint of the side AC. Thus the line L bisects the third side AC. So it is proved. So in this theorem, what you did, first we have drawn through this vertex C a line that is drawn parallel to the side AB. Then comes the proof part. In the first condition, you have made quadrilateral BCFD parallelogram. So by making it parallelogram, you have got CF equals to BD. Opposite sides of parallelogram are equal. But it it is given that D is the midpoint of the side AB. That is why AB equals to DB. This one is given. So by comparing the equations, you have got AB equals to C. Then you make the final step by making these two triangles congruent. You have made it AE equals to CE. That means E is the midpoint of AC, that is true, CP, CT. Thus the line L bisects the side AC at point E. Proved. Let us take question number 4. So it is given that ABCD is a trapezium. AB is parallel to DC. BD is a diagonal. And E is the midpoint, of AB. A line drawn through E, so EF, a line drawn through E, parallel to AB, intersect BC at F. Now to prove F is midpoint of BC. So the figure is given. So it is given that ABCD is a trapezium. So ABCD, this is a trapezium where AB is parallel to DC. So the side AB is parallel to DC. BD is a diagonal. So this BD is the diagonal, and then E is the midpoint of the side AB. So here E is the midpoint of the side AB. That means these two are equal because E is the midpoint of the side AB. Then a line drawn through E. So through this point E, the line is drawn parallel to AB. So this line drawn through E, that is the line EF, parallel to the side AB. So parallel to AB, intersect. So that means they will meet the side BC. So BC and F. So this line drawn through E, that is parallel to the side AB, they will meet the side BC at point F. So as they have not given here any name, let us give this point as G. Now here you are to prove that F is the midpoint of BC. So children, you will have to keep two things in mind. Regarding the midpoint theorem, you will get on two sides of the triangle, you will get midpoint. Say this is A, B, C, D and E. So if there is a midpoint theorem, in that case on two sides of the triangle, say the two sides you can take as AB and then AC, on these two sides you will get the midpoints D and E. So there will be two midpoints. In that case there will be the midpoint theorem. But if it is the case of the converse of midpoint theorem, which you did just now, In that case, they will be giving only one side. Only on one side there will be a midpoint, and through this midpoint the line will be given parallel to the second side. That is said here, D is the midpoint of side AB. Through this D, the line DE parallel to BC. Then this line DE will bisect the third side. That is E becomes the midpoint of the side AC. So that will be the converse of midpoint theorem. So now here they have given that this is a trapezium where AB is parallel to DC, and here E is the midpoint of the side AD, and through this E they have drawn the line that is parallel to AB that will meet the side BC at point F. You are to prove that F must be the midpoint of the side BC. So here you have got two triangles. One is the triangle DAB, next is the triangle BCD. So let us, here you will be using the converse of the midpoint theorem, because if this is a triangle, they have given that E is the midpoint of the side AD, and E is the midpoint of AD. So that means only on one side they have given midpoint. So here, and then they have given that EF is parallel to the side AB. That means the line drawn through the midpoint of one side of the triangle. So the triangle is DAB, one side is AD. On this side is the midpoint, and through this point the line is drawn parallel to AB. That means the line drawn parallel to another side. Now this will bisect the third side. So here the third side is DB, because the triangle is DAB. First side is DA, where means is the midpoint of the side DA. Then this through this point E, the line is drawn parallel to the side AB. So here the line drawn through E, so through E parallel to AB. So this line is parallel to AB. That one is given. That this line will bisect the third side according to the converse of the midpoint theorem. So now here comes the proof. So it is given that AB is parallel to DC. So here AB is parallel to DC. This one is given. Also it is given that a line drawn through E parallel to AB. That is the line, that is this line that is drawn through this point E parallel to AB. That means EF is parallel to AB. So EF parallel to AB. This one is also given. So it is given a line drawn through E parallel to the side AB. So from this two you will get AB is parallel to DC, AB is parallel to DC, AB is parallel to EF. So here AB is parallel to DC, AB is parallel to EF, which means here you can say that DC is parallel to EF. So DC is parallel to EF. So that means these two lines are also parallel. Because the three lines are parallel to, that means each other. AB is parallel to DC, AB is parallel to EF. Naturally, EF is also parallel to DC. So you got it. Now in the triangle DAB. So in the triangle DAB, so what they have given, E is the midpoint of the side AB. So here E, midpoint. So E is midpoint. E is midpoint of AB, and the line drawn through E parallel to AB. That means the line, that is this line EF, that is drawn through this point E parallel to the side AB. That means EG is parallel to AB. So EG parallel to AB. So now this converse of midpoint theorem, let us go to the statement. The line drawn through the midpoint of one side of the triangle, which is the triangle DAB. So the line drawn through the midpoint, so the midpoint is E, one side is AB. So through this midpoint the line is drawn parallel to another side, that is the side is AB. This is the second side. This is the first side. So then the side DB becomes the third side. So S here is the midpoint of the side AD, and through this E the line is drawn parallel to AB. That means EG is parallel to AB. Naturally, G will be the midpoint of the side DB according to the converse of the midpoint theorem. What is the converse? The line drawn through the midpoint of one side of a triangle parallel to another side bisects the third side. That is why, since here E is the midpoint of the side AD and then EG is parallel to AB, naturally G is the midpoint of the side DB. So therefore G is midpoint of side DB. This is through the converse of midpoint theorem. Converse of midpoint theorem. Next you take the triangle BCD. So in this triangle, BCD, what you have got? So as we have proved that G is the midpoint of DB, so in this triangle now G is the midpoint of the side DB. How? So it is proved above. And then GF is parallel to DC. Why? Because you have proved that DC is parallel to EF. So DC is parallel to EF. So if DC is parallel to EF, that means GF is parallel to DC. Now you see in this triangle, the line drawn through the midpoint. So this is G is the midpoint of the side DB. You have proved just now. So through this midpoint, the line is drawn parallel to another side. Which is the side? That is the DC. So this is the first side, this is the second side, and this will be the third side. So the line then they will bisect the third side. That means F is the midpoint of the side BC. So in triangle BCD, G is midpoint. G is midpoint of DB. Why? So you have proved above. So it is proved above. And then GF is parallel to another side. That is the side DC. So GF is parallel to DC. GF parallel to DC. Why? Because we have proved that DC is parallel to EF. So DC is parallel to EF. So because DC is parallel to EF. Now you see, according to the converse of the midpoint theorem, this is the triangle BCD, where G is the midpoint of the side DB. And then you got that through this point G, you have drawn the line parallel to the second side, that is the side DC. Then this line will bisect the third side. So the third side is BC. That is why F is the midpoint of the side BC. So therefore F is the midpoint. F is the midpoint of side BC. So this is by converse. You have got it by converse of midpoint theorem. Midpoint theorem. So it is proved. So that's all for today. Thank you.